Hi, welcome back. In this video, we will introduce group fairness metrics. Group fairness metrics compare statistical quantities of groups which are defined on the basis of certain attributes in a dataset. For example, groups of people defined by age, gender, location, or other classifying attributes provided in a given dataset. Data scientists and programmers use group fairness metrics to compare algorithmic output based on either the distribution or the accuracy of data output concerning different group attributes. One type of output distribution comparison is statistical parity, which measures the percentage discrepancy to which a certain output is distributed among two different groups. An example of statistical parity measurement might be calculating the percentage difference between male and female job or credit applicants having their application accepted. This metric mirrors the idea of equality we described above. We can use it to detect asymmetries in the distribution of a certain output, but prescinds from consideration regarding the reason of the unequal distribution. In contrast, another type of data output distribution comparison is conditional statistical parity. Conditional statistical parity is defined in the same way as statistical parity, but restricted to a data subset characterized by attributes A. In other words, conditional demographic parity is violated if, for a set of attributes A, the protected group is to a larger extent represented among those with non-preferred output and attributes A than among those with preferred output and attributes A. This metric is a step towards the idea of equity we described above, because it considers as specific individual attributes that are particularly relevant for a certain prediction, instead of just analyzing the output distribution in the whole population. Note that an algorithmic output evaluated as fair by the statistical parity metric might be evaluated as unfair using a conditional statistical parity metric, and vice versa. Two popular metrics that compare output accuracy are the predictive parity and equal opportunities metrics. Assume that an AI system is predicting whether job applicants are fit or unfit for a job. For the predictive equality metric, a classifier is fair if both protected and unprotected groups have equal positive predictive value, meaning the probability of a subject with positive predictive value, in our example of someone being predicted to be fit for a job, to truly belong to the positive class. In contrast, for the equal opportunities metric, a classifier is fair if both protected and unprotected groups have equal true positive rate, meaning the probability of a subject truly belonging to the positive class, in our example, someone actually fulfilling all the job requisites, to have a positive predictive value. Intuitively, also in this case, an algorithmic output evaluated as fair using the first metric might be evaluated as unfair using the second one.